Okay, so today we're talking about evaluating functions. This is very similar to what we've been doing this week, but it's just a little different way and a little different notation for how to represent it. Okay, but before we get into evaluating functions, here's some definitions that I think we should get down pat because they're very important words to know. The first two, especially, you're going to see those on the park quite a bit. All right, so the domain is the set of all input values. Now, when I say input values, 99% of the time we're talking about x values. When you think about the xy coordinate system here, the input is always along the x-axis. Okay, the input values, that's the distance right or left on this graph, but it's not always represented with an x. One thing you'll see in the next example is we've got something like this, where you have the function g of t equal to something, whatever it is. This t inside of the parentheses, whatever's inside of the parentheses, that's your input value. Okay, so in this case, the t is our x value. So if we were going to make a coordinate out of this, the t coordinate would be our input, that's the first coordinate, and our output would be the function itself, g of t. So just because I say x and y doesn't mean that it's always going to be x and y. You have to look at the notation that they give you and pull it from there. The thing inside the parentheses, that's the domain. It's the set of all input values. The range is the set of all output values. On this coordinate graph, it's the up and down axis, that y-axis. And again, this is one of those things where we call it y, but most infrequently it can be f of x, it can be y, or in this case it'll be g of t. Our y value here is g of t. So this t here, this is our x value, our x coordinate. G of t is our y coordinate. So those are very important to remember. Just think domain, x-axis, range, y-axis, up and down. Okay, and then a relation, that's just a definition that we need to know. A relation is just a set of ordered pairs. Okay, now a relation can often be a function if it passes the vertical line test. So remember, we talked about if we have a set of coordinates, if you look at the x coordinate on all those coordinates and none of them repeat, then it is a function. If it's not a function, then we'll just call it a relation. Okay, so a relation is just basically just a set of ordered pairs. So those are some definitions. You want to kind of keep those in mind because they're not going to go away. All right, so now we're going to get into the meat of actually evaluating functions. So look at the directions up here. It says to find the range of each function for the domain. And this is why we talked about the domain and range. The range, they want you to find the output. All right, f of x, y, g of t, for the input domain, and then they list the numbers. So what they're basically saying is, since they're saying this is the domain, they're saying, well, let the x equal -2 and plug it in. Let x equal 0, plug it in. Let x equal 5, plug it in. So what we're going to do, and the notation we use with this is going to be a little different. I want you to get used to seeing it though. We're gonna grab this x and we're gonna take it out, and what we say here for the first coordinate, we're going to put in -2. So this is f of -2 is equal to, now notice the way I have this written here, this is not f times -2, don't get confused. This is function notation, all right? This is the common way in which we might see if we're going to put a value in for x, they'll put it in that parentheses. So this on the left is not something to solve or anything like that. That is the same as saying, well, y is equal to this, all right? So f at -2 is equal to, now we're going to grab the other x, we're going to take it out, and we're going to replace it with -2. So f at -2, that's how you read that. F at -2 is equal to -2 minus 6. So our answer here is f of -2 is going to equal -8. So for domain -2, input -2, output is -8. So your coordinate from here would be, if you were going to write a coordinate, you don't have to. Your coordinate, your input value is -2, your output value is -8. All right. Now we're going to do the same thing with the other two numbers that they give us. So in this case, we're going to lift out x and put 0 in. So f at 0 is equal to 0 minus 6. So f at 0 is going to be negative 6. So there's our second answer. And then finally, we're going to lift out x and we're going to put 5 in. So take out x, and put 5. So f at 5 is going to be 5 minus 6. So our answer here is f of 5 minus 6 is negative 1. Now if you wanted coordinate points, this would be 0, negative 6. This would be input is 5, output negative 1. So there's your coordinates. Okay? So what I want you to do is take a second and try the next two on your own. Pause the video, and then whenever you're done, unpause it and I will explain how to solve. Okay, so we're doing the same thing. Notice here we've got y instead of f of x. So since we're putting in 3 different values for x, if you want to differentiate the different y's based on what you put in for x, another way of writing this would be to put a little subscript here. So we're going to go with negative 2 first. So put a little negative 2 there by the y. And that's a perfectly legitimate way of writing y at negative 2. Okay, so when you don't have the f of x notation, you can put a little subscript on your y to make them different. And the reason that you do that is you're going to get 3 y equals, so it's helpful to tell to see which value of x you plugged in when you did that. So we put in negative 4, we're going to lift out the x, we'll put in negative 2. So y is negative 2 is equal to, y at negative 2 is equal to negative 4 times 2, which is a positive 8. Alright, do the same thing for the rest of them. Y at 0, we're going to do negative 4 times 0. So negative 4 times 0 is 0. Put in 5, y at 5 is going to be negative 4 times 5, which is negative 20. Okay, now notice in the third one over here, we don't have an x or a y anywhere, and I explained that in the previous slide that I had. Notice this is your t is your input value. So t is what we're calling the domain here. So the t is the same thing as x. Okay, so in this case we're going to lift out t and put these numbers in. So you can do that the same way we did over here. G at negative 2 is equal to, now you're going to take out t and put in negative 2 squared. So g at negative 2 is equal to negative 2 squared is 4. 4 plus 1 is 5. Now that's perfectly legitimate. Now you can also, if you don't like writing it like this, I want you to understand it when you see it, but you don't necessarily have to use this notation. You can also do what we did before. You can make your own function table from this if you want to. Notice in this case your input is t, so your function table on the left would have t, and then on the right your output is g of t. And then basically for the domain, you're basically just, instead of picking numbers for t, you're just putting in the numbers that they tell you. Negative 2, 0, 5. This is perfectly legitimate. You can use a function table to represent these answers if you like. So if you put in negative 2, we've discovered that you get 5. If you lift out the t and put 0 in, 0 squared plus 1 is 1. If you lift out the t and you put 5 in, 5 squared is 25. 25 plus 1 is 26. So there's a couple of different ways that you can see this written. I want you to be familiar with this F notation, G notation, that stuff, because you will see that more on the part. If you have any questions, bring them to class.